Alright, graphing exponential functions. Let's take a look at the first one and just see what's going on with an exponential. So this is 3 to the negative 2. This would be 3 to the 0 and 3 to the 2. I'm just plugging in the x values. So with a negative, we flip it. So this is 1 over, and then 3 squared would be 9. And then we get 1, and then we get 9. Okay, so let's look at this one again. 1 half, negative 2, 1 half to the 0, and 1 half to the 2. We're just comparing these to see what's going on. So this one flips it and squares it. So if you flip the 1 half, you get 2. And 2 squared is 4. Anything to the power of 0 is 1. And then that would be 1/4. So if you notice, we have fraction, 1, and then whole number. Whole number, fraction, whole number, 1, fraction. We're getting a 1 in the middle, and that's what we're looking for with exponentials. We want that pattern. We want that fraction, and we want that whole number. If we get the 1, that's great too, but we want a fraction and a whole number when we're graphing these. And it looks like this. You have negative 2, and then 1/9. And then you have 0, and you have 1. And then at 2, we have 9, which is off the charts up here. So when we graph it, it looks like that. That's what an exponential looks like. This right here is actually approaching this line. There's a thing called a horizontal asymptote right here. The whole thing with exponentials is they will never equal negative unless there's a negative in front of it. But you cannot plug any number in here that will turn this whole number negative. So there's a horizontal asymptote here. And it looks like this. So one side is approaching the asymptote. You never want to cross it. So never cross. And the other side is going off into infinity. It's growing very quickly. It's called exponential growth. So let's look at this one. This is a fraction version. So we have negative 2 and 4, 0 and 1, and then 2 and 1/4 right there. And it's the same exact thing, but going in the other. This is like an exponential decay. And the same idea, there is a horizontal asymptote right there, and it will never cross it. And this is what you should be getting for every exponential, either going in this direction or in this direction. It could also be below, but the same exact idea. One part going towards the asymptote and one going away. So we want part towards, and then we want a part away. That's what we're looking for. So we're looking for whole number, and we're looking for fraction. So here's our steps. There's only 2 of them. First thing to do is to find the horizontal asymptote. And here's how you can find it. Here's the graph of this one. This is the graph of this one. And this is the graph of this one. So the horizontal asymptote here is y equals 0. So remember, y equals are the horizontals. This is y equals 1. And this is y equals 3. Do you see a connection between each of these? Exactly. It's that number right here. That is what's going to give you your horizontal asymptote. So whatever's being added to your exponential, that's your horizontal asymptote. And then once you have that, you're going to translate it or plot lots of points, okay, until you get fraction whole number. So what's our horizontal asymptote for this one? It's 0. And what's the horizontal asymptote here? It's 2. So let's graph those horizontal asymptotes for both graphs to get them started. So there they are. And we use a dotted line because it doesn't actually exist. It's just kind of like a little barrier that's there that our graph is approaching. In this case, it literally is a barrier. All right. So what we have to do now is find some values on here that will give us fractions and whole numbers. And I always use this value right here. We want to make this numerator 0. So that numerator, that exponent, 0. Because when we had the 0, that was the separator between our fraction and our whole number. It also gave us the 1. So if we had that 0, it gives us the 1. We need the exponent to be 0. So if we can find a value of x that gives us 0, then we know exactly where to start. So once we have that, we plug it in. 2 to the negative 1 plus 1. That's 2 to the 0, which is 1. So now we know exactly where, kind of like I like to think of it like the changeover from fractions to whole numbers is. So if we pick 1 point to the left and 1 point that's to the right, 1 point to the left, which is -2, and 1 point to the right, which is 0. Little brain fart there. Now we can plug it in. So 2 to the -2 plus 1 is 2 to the -1. And again, we flip it. So 1/2. There's our fraction we wanted. So it's -2, 1/2. Now this one's going to give us the whole number we want. It's 2 to the 1, which is 2. So at 0, it's 2. And you can now see the exponential shape that we want. So this side goes off to infinity, and this side approaches the asymptote. But remember, do not cross this line. Just get it close to it. All right. Same idea. So -x equals 0. So x would be 0. That's the value we should use. So 1 point to the left would be -1. 1 point to the right would be 1. Plugging them in should give us what we need. So this is -3 to the 1. Negative times a negative is positive. And that's -3 plus 2 is -1. So we have -1, -1. And then 0. That's -3 to the 0, which is 1. -1 in this case. Plus 2, which is 1. So it's 0, 1. I graphed that one incorrect. It's -1, -1. And that one's 0, 1. Okay? And then we plug in the 1. And so since we got a whole number here, the -1, in this case is an integer, this one should give us our fraction. So we have -3 to the -1 plus 2. That's -1/3 plus 2. And then adding those together, that would be 6/3. So 5/3. 2 2/3. 1 2/3. So it's 1 and 1 2/3 right there. And now it doesn't really seem that way, but you can tell from this point, this one's going off to infinity, and this one is approaching the graph. And there it is. So like I said, some will be below the graph. It's because of the negative. Because of the negative, it's inverted. So it was up here, and we put a negative in front, it flips it down. Okay, one last thing, domain and range. Now that we have this, our domain on each of these is going to be all real numbers, because we don't have any restrictions. You can plug anything you want into an exponential, but we do have a restriction on range, and it's all about that asymptote. So in this case, the lowest point on our graph is the asymptote, which is 0, and our graph will never hit it, so it must be a parenthesis. And then it's going to go off into infinity, like that. And on this one, the lowest part is -infinity, right down here. And then the highest point is the asymptote of 2, parenthesis. If you notice, there are no brackets here, because one side's going off to infinity, the other one is approaching something that it will never hit. And there you go. Thank you.